Good morning, Year 5, and welcome to your Thursday maths lesson. Please record today's date and learning objective in your book, remembering that today we're completing the second half of the worksheet that you had yesterday. Complete your flashback 4, pause, and use it to help you check your answers afterwards. Let's see how you did. Did you get these answers? Pause the video, mark each one, and then come back to me. For number 4, write down any 5-digit number. So long as the 6 is in this position, you've got it correct. Let's move on to today's learning. So today, we are still comparing and ordering fractions that are less than one whole one. Let's have a look at our skills to get us started with that. Compare and order fractions less than 1. Let's get ready. Using your skills we looked at yesterday, put the fractions into the correct box. So working out with these 4 fractions here, whether it's less than half or more than half. Pause the video, come back to me when you've had a go. Well, let's have a look. First of all, let's have a look at 4/6. What would half of 6 be? 3. So 3/6 would be the same as half. So 4/6 must be more than half because it's more than 3/6. Let's have a look at 14/29. Why is it less than half? Well, half of 29 would be 14.5, and 14 is less than 14.5. Let's have a look at this one. Why does it go here? Well, 8/4 means I've got one whole one, 4/4, and another 4/4, so I've actually got 2 whole ones. That's definitely more than half. What about this one? Well, double 50 would be 100, but I haven't got to 100, I've got 99, so these pieces are greater than hundredths. So this needs to go in more than half. Half of 99, have a think. Yes, it's less than 50. So 50 is greater than half of 99. Let's have a look at number 2. Here, the numerators are the same. And for this to be true, this statement's saying that this fraction is greater than this fraction. So let's think what we learned about that. This number on this side needs to be bigger because we're making the pieces smaller in the whole one, so we can fit more pieces in. So 13, or in fact any integer that's bigger than 12 would go there. Here, 11/8 and 10/4. Well, we can't compare them as they are, so we need to change them so they're both the same. Well, this is tricky, but this is not. We could change quarters into eighths. What would I times 4 by to get to 8? 2. So do the same to the numerator. 10 times 2 is 20. 20/8. Now we can compare them. 11/8 and 20/8. Well, 20's got more and 11 has less. Therefore, 11 is less than the 20/8. Let's learn for today. We need to look at writing fractions in ascending order. Ascending order means the pieces get bigger. The amount of space they take up is bigger. So we start small and we get big in value of size. Let's have a look then. All the numerators are the same. The denominators are different. Remember this rule? When the numerators are the same, the greater the denominator, the smaller the fraction. Therefore, having a look here, which is the greater denominator? Because that's going to have the smaller value, the smallest fraction. So this one is first. Then this one. Then 5/11, and then 5/6. That is in the correct order, going from ascending, so smallest fraction to largest fraction. Let's apply that learning here. Bit tricky now because none of them are the same. So we've got to think what we need to do. When the denominators are the same, the greater the numerator, the greater the fraction. Let's have a look at those denominators, 16, 8, 4, and 8. I can see that they are all multiples of 4. And in fact, we could change them all so they're all 16ths. Let's do that to help us. So what would I do to 8 to make it into 16? Double it. So double 5 is 10. What would I multiply 4 by to get to 16? I'd times it by 4. Do the same to the numerator. 3 times 4 is 12. 12 16ths. What would I do to 8 to get to 16? Times by 2. So I do the same to my numerator. 2 times 2 is 4. Now you can see that I have 4 where the denominator is the same to do my comparisons. So which one is the smallest? Well, 4 16ths is the smallest, but which fraction originally does it link to? 2 eighths. So we can see here that 2 eighths will go first because 4 16ths is the smallest value out of these. What's the next smallest value? 10 16ths, but it links to this fraction, 5 eighths. So that's the one that goes into the box. Now I have 11 and 12. So 11 was my original fraction, goes here, and the one that is equivalent to 12 16ths, 3/4, goes here, is the greatest fraction. Let's apply that knowledge to this one. Have a look carefully. We've got 2, 10, 5 and 5. We could change them all into tens. So think what you would multiply each part by to get to 10. Let's have a look. 2 times 5 is 10. So 1 times 5 is 5. 5 tenths. Here we don't need to change it. This one, 5 times what is 10? 2. So do the same to your numerator. 4 times 2 is 8. 8 tenths. And again, we're multiplying by 2 to get to 10. So we times the numerator by 2, which is 4. Now we can compare the tenths. We have 5 tenths, 3 tenths, 8 tenths, and 4 tenths. So the smallest one is 3 tenths. And we can see the others put into the correct order. I hope you got those correct. Let's have a look at this one. Now, if we look at the denominators, they're going to be tricky to change. Let's look at the numerators this time. Could we change them all into something? Yes, we can. We look carefully. We can see that when the numerators are the same, the greater the denominator, the smaller the fraction. So let's make all of our numerators the same. We're going to change them all into 14ths. So this one's already 14ths, we don't need to change it. To get from 2 to 14, we multiply by 7. 5 times 7 is 35. 7 times what is 14? 2. I'm doubling. So 9 times 2 is 18. 14 18ths. Last one. 3/3. Well, that's the same as 1 whole one. And if I look at these, in each one, none of them are more than 1 whole one. So this has to be the greatest. So that's going to go in there before we start. Now we can compare these 3 that are left. Remembering that the greater the denominator, the smaller the fraction. So now we can look at the denominators. And 35 is the largest denominator, so they're the smallest pieces. That's going to go there, remembering to put the 2/5 in that it was equivalent to. Now we're looking at 14 18ths and 14 33rds. Well, this is going to be smaller, and that's the original fraction. Then it's going to be this one, and that's the original fraction. Now they are in order from smallest to greatest. Let's pause the video and have a go at these ones, thinking about when the numerators could be made the same. What could they all be made into? They could all be made into 6 as a numerator. Pause the video and have a go. Shall we see how you did? So what would I times 1 by to get to 6? I'd times it by 6. So I do the same to the denominator. And I get 42. So it's 6 over 42. What would I multiply 3 by to get to 6? I'd multiply it by 2. Do the same to this, multiply it by 2, and we get 6/16. Moving along, going from 2 over 9, what would I do to 2 to make 6? Multiply it by 3. Do the same to the denominator, times it by 3, and we get 6/27. We now have all the numerators the same, so we're looking for the greater denominator to put first. So the 6 over 42 is the greatest. So we can see that that will slide the 1/7 down. Let's see what's left. What's the next greatest denominator? Yeah, 6 over 27. So that's going to slide the 2/9 over. Now we're comparing 6/16 and 6/13. 16 is a greater denominator, so it's a smaller fraction. So 3/8 goes next. And lastly, 6/13 is the greatest. Let's take it to more of a problem solving this time. What is the missing denominator? Well, here we can see that it will be hard to compare 23 and 13. Let's look then to the numerators, 16, 2 and 8. We could change each of those into 16. Let's do that. Here, 8 times 2 is 16, so 13 times 2 is 26. We can compare these now. Let's change this. What would I multiply this by to get to 16? I'd multiply it by 8. So we know that whatever goes here is going to be a multiple of 8. Between 23 and 26, which is what this has to be, there are only 2 possibilities, 24 or 25. If I put the 25 there, is it a multiple of 8? No, so it can't be 25. It has to be 24 because 24 is a multiple of 8. 16 divided by 8 is 2. 24 divided by 8 is 3. So therefore, the number that was missing in the original calculation is 2/3. Have a go at questions 5 to 7 on the worksheet. And I'd like you to record it, please, like this in your book. So for question 5, you're going to stick it in and then say whose method you think is more efficient and explain why. For number 6, to put the fractions in ascending order, you can see how to lay it out neatly in your book, and I've put a reminder here of what ascending order means. Continue in your book until you've completed the second half of your worksheet, and if you're ready for the challenges, definitely red group, move on to the next page. Red group, you're going to stick each challenge into your book and show your working or your explanation at the side. So read it carefully and then use the sentence structure, I disagree with Ron, and give the reason why, because you can use maths to prove why. Always, sometimes, or never, read the statement and then it's got an example and how you could prove it. Now for this the answer is sometimes, so I need you to give me an example when it doesn't work for some fractions and give me some examples, and give me some examples where it does work for other fractions and give me examples. Good luck with your challenges today. At any point if you need to, you can go back and re-watch any part of the video to check your knowledge and understanding. Remember to draw it if you need to. Good luck and see you for our next lesson tomorrow.